Hello everyone. I'll go through a few example assignment 2 submissions today to give you a little bit more sort of feedback. Those of you who had good submissions or okay submissions, not all of you got a lot of feedback, so I'll go through a few, and hopefully this will also clarify and help you what we're looking for in some of these practical model-based testing questions in the written exam, which will be on Wednesday. So yes, I'll go through a few. I haven't looked at all of them in detail, so maybe I'll get into some details where I mess things up a little bit for you, because I'm trying to keep things simple and do it as we go through. Okay, so here's one example: modeling and model-based testing. So I try to make this a little bit anonymous. But most of the things I say here is not about the particular assignment we're looking at. It's to highlight general things. So just one important thing when you do a report in any course, or when you write and answer questions in the exam, is to be really clear on, for example, it doesn't really say in this report which assignment am I looking for and what's the context and so on. So here I would like to have seen a little bit more of an intro and context. This is not a major thing, of course, but it is important when you do these type of reports in courses. Otherwise, very good here to have a general description. So this seems to be about the library I've chosen to model is the ArrayList library from Java. So this is a data structure which is available in standard Java, core in a sense, base. Which is so it's low level, unit level testing here. So just a point of note that it's this is good for the assignment, of course, can be, and we didn't have any requirements on this, but in general model-based testing probably would more be used on a slightly higher level, like integration or system level, at least when you incur the costs of developing a larger graphical model and so on. But of course you can do it on any level. It's a sort of a way to capture behavior and logical relations and dependencies between different states and what are the transitions and so on. So it can be used on any level. But from a real for the assignment this is good, but from a realism perspective, we would probably use it on integration level, maybe more complex pieces of the code or system level. Okay, so what do we have here? A description of the behavior of the model part of your SUT. Yeah. It enables creation and alteration of an array list. The model is a downscaled version that is limited. So very good. Stating the limitations that you're going to focus on, right? Because someone else coming into your report might not know exactly the trade-offs, and they might be utterly confused, right? So it's very important. Say you would do a model for model-based testing in a company. Very important up front to see which parts of our system, which subsystem are we focusing on, and why, probably, right? I mean, what I lack here, well, it could have been even better if you said, why did you select this? But maybe this is for an assignment, so there's not really a why maybe, but in reality you would say something like, we've selected this subsystem and these particular actions because they have a complex dependency with the database, or whatever it is, right? Try to clarify why you have done a certain limitation, because this is important for someone else updating your model, understanding the tests, even debugging. It's important for them to know what did you focus on, why, and why didn't you select other parts, right? So we go on. The model also includes a function that is not visualized in the library. It's a little bit, just the English of this sentence makes it a little bit hard for me to understand. Let's read on. because function, many of the terms in this sentence are quite general, so it would have been better if you gave a little bit more detail on what you mean here, not visualized. Okay, so I think I get it. When initializing an array, it gets a standing capacity of 10. So this is kind of like an implementation detail then, about the implementation of this data structure. So it's a good thing that you thought about this and that you actually model it. So when the size of the array list is larger than its capacity, the library increases the capacity. So this is a standard way that data structures are implemented in practice, and it's good that you model this. I would have liked a little bit better explanation of what's coming here, because the start here was a little bit confusing. So this is done automatically. So to model this, I chose to represent it in an edge after adding an element to the radius. Okay, fair enough. Yeah, that makes sense because it happens automatically, so it's not really a difference in state. Of course it is, because you know all the states in somehow are affected by this, by the fact that you know you have almost versions of some states, because of the capacity might change later behavior. But then it's probably smart to do what you did here and represent that in a variable or in some action to update that variable. So that makes sense to me. We go on. So you see here, this is also good. Not only to list the system inputs in your model with their description, but also have the description here, right? So you have to build up so that the someone who's going to use and maybe extend your model, they need to understand what you're doing. So it's probably a little bit more context would have been nice here, but this is good to clearly describe here what are the different. I'm not sure it's only inputs here, so you know maybe you could have clarified a little bit what you're doing here. But it looks nice when I get into the text. So array list add an object, of course, adds a specific element, removes clear is kind of like a reset to array as list array. So this is some kind of conversion between different data structures here, right? Transition table. It's probably going to be quite simple for such SUT or yeah, what we're. So you have state before, input, state after. So this is, I think, what Jan showed you in the slides. Of course, in practice in finite state machines, you also often see the state input format. So then you would have slightly different tables. You would have in the leftmost column you would have the state before, and then on each column you will have different inputs, and then in the cell intersection you would have the state after. So that's a slightly different way of doing it. I think I have one here. Here's a two-dimensional state transition table. So it's probably easiest to see from an example, right? So here's the two-dimensional. So you have current state here in the leftmost column, and then you have the specific input, and then you have the state after here. So this corresponds to this, but you know it depends. If you have a large graph where the inputs are quite different in for different states, the 2D one will be mostly empty, so then it makes more sense maybe. So in practice, this is the 2D one is probably for simple textbook examples quite often, while the one that Jan has shown you in his slides and videos is this one is maybe a little bit more realistic. But this is just a kind of a table summary of a graph, right? Because it shows basically the edges here, right? This is from a source to a destination node or vertex, and here's the edge. The input or action can be, you can even have guards here, I guess, if you want to. So a graphical representation of the model, and we need to rotate this for me to show it to you. So let's see, where are we? Okay, so we start from some start state. Well, it's not really a state, but it's where we enter into a model. We come to a vertex called declared array list. Okay, so that's that. And then we have on init this, here comes the internal variable length. So probably he has checked the implementation of Java array list and found that the length was 10. So, and here's more of a variable that we use in our model, right? Well, both are, but this is sort of mirroring something that happens inside the soot, while this one is something we have in our model as a help to see the transitions and model what's going to happen. So first we have declared an array list, so I guess this is a type declaration, and we have now a reference to it, and then it will be okay. So this is initialized when we create a new empty array list, and then the internal capacity length is set to 10 and it has 0 elements, right? So then we can have the transition add first, and then yes, we will have a non-empty array list. So maybe there's some good reasons to introduce this node, because you could imagine that that was probably not here. So no, this is good, this is needed, because there will be some actions that cannot happen on an empty array list. So this, I think, is sort of the main reason to have this. So you can have this state splitting, but of course, where do you draw the line? You can always introduce new states, and this could make for a more complex model. And when you have more states, you can then refine your description of the behavior, right? So you could have here not only non-empty, you could have containing 1, containing 2. You could sort of model the whole capacity thing with vertices instead. So this is a little bit, here's more of an art than a science, right? I mean, so how do you decide how many states you need and so on? So you should keep it down, right? So it's better to have logic or variables in general sense than to have sort of an exploding model with many. Okay, sorry for that. I don't want those messages right now. Okay, let's go on instead. We see initialized with empty, we add a first element, then we come to a non-empty array list. What can happen then? So you see, when I go to a node like this, I look for outgoing edges, because that's going to determine what can happen. So what can happen? We can remove again. So then we will take away the number of elements. Yes. So we say we had 1 and now we take it away. Do we go here? So we'll be back at 0. Here's a weight. So this is one thing about GraphWalker, and a thing which is they don't have good separation of concerns, right? So this is part of our model, but this is a hint to the tool about how it should generate data or how it should traverse and so on. I'd rather have this sort of separated out. I'm not talking about this solution, I'm talking about tools should allow you at least to not show these tool-specific things, right? You should be able to have views, which is only the model, and then have tool-specific things. So this is more tool-specific. Anyway, this is a weight to see basically what's the likelihood or probability to go take this action and do this transition. So we can do back to 0. So here we could have gone to empty, but remove last. Okay, so that's a little, okay, yeah, so it's a guard. So we will fall through here if we were here having a single element. We would go here, take it away, and then we will fall through on this guard here, right? Because we would have a number of elements would be 0. This is a little bit unneeded, unnecessary, because the way we specify this, there's probably no way that number of elements can be below 0. So, but it's not formally incorrect, right? It's just like The downside of adding something like this, which is not necessary to understand the model, is that someone looking at this after you, or you a year later, might think there is a reason for this, and then when they don't find it, it could add confusion, and you don't want that. Okay, what else can happen? So if we were here, we add one element, we add another element, and now let's say we're adding to array list. Right, I'm not sure of the naming of this one, but okay, fair enough. Naming is hard, so it's not a big complaint, but maybe something more descriptive, because this sounds more like a verb, but what you want in your state is state, more static things, right? You can hear it in the name, state, static. So if possible, try to have some, what should we have here? So here was non-empty, here it was, we were adding, so it was, yeah, it's a little bit unclear what would be a good name. Let me see what's happening here. So we're adding here, we are now at 2, keep size. Number of elements is below the capacity. So this is okay. So this is a node added to handle the logic around the capacity. So then I think that's fine. You could even have some kind of prefix on this one, so that you make a difference between your nodes, which are sort of action nodes or introduced to capture logic, and ones that are more static. That's probably what I would recommend here to make it even more clear. So this one we need to model this kind of logic going on internally. So what can happen? We add, we have 2, and then the length was 10, the internal capacity was 10, so we could keep on adding, right? So we could go around here, and the only thing that happens is that we take this loop because we are below the capacity, and then at some point we will have to increase the internal capacity. So here again, a little bit problem I see with this model, not problem, but you know, a refinement would be to have more consistent naming, right? Length, so maybe call it capacity and have these names of the nodes and the logic clearly named, so that you know that all of this is part of the capacity or size kind of internal logic. So now it's a little bit confusing. You're using length, you are increasing, you're using size, length, and capacity in the text. So it's like 3 concepts for essentially the same thing. So that would be a refinement. Okay, so here's probably how it's done in the Java implementation, how the internal capacity is increased. So this was the guard from here. So I generally like to have the guards up front because then it's more clear that the guard is kind of the first thing that happens. So it's a little bit easier to think about it in time. Then we go back to non-empty, and what is this? So this is also non-empty array. This is the type conversion between things. So we can convert an array list to an array, and then we can go back to a list. And what is this? This is the reset. So there we can jump from any state, any number of internal elements, to an initialized but empty array list. So removing, I think we've covered most of it. Looks good. I mean, you can see that it's very simple logic that's being modeled here, and it's still 5, 6 different nodes and quite some. So you can imagine when the logic is much more complex, this will grow a lot. But you can also see some benefits in this, right? I mean, you can really model, and the hard thing is to decide what do you include in your model, what's the right abstractions, and so on. But I think overall this is a good one. A little bit about the naming and a little bit better introduction would have made it even better. And then we have some comparison. It's always good to have a table to simplify. I've seen some assignments where you didn't use a table. So this is good here, showing some runtime for different, and it seems that the weighting in general helps for edge coverage, but not so much for vertex coverage. But here you can see some benefits, that you need to generate fewer or shorter test cases to cover probably everything. So I think this looks good overall. You are describing what you're doing. This is also good. Not only put data in a table, you have to describe where do I get it from, how did I do it, why is it a good way to do it like this. So here I lack a reason. The runtime is taken from the IntelliJ UI. Okay, so why? Okay, because it's easiest, or because it's good, because who knows. Clear improvement with running the weighted. Okay, good. And some analysis. Running a test in the console. Okay. To summarize, using weighted edges is beneficial for achieving 100% edge coverage in less time. Okay, fair enough. No benefit for vertex coverage. A description of 5 tests you are conducting with your model. So this was a little bit unclear here. What do they test? How to fail them? Throughout the model that I created, I run the following line of code to test assertions. Assert that equals get attribute number of elements. So yes, from the model, I guess. Array list adapter get array. Okay, so checking all this time that the number of elements is fine. Okay, this is good, but it doesn't really answer the question of the 5 tests. This is one assertion, but what are the actual tests? I understand that you run it on multiple transitions, or even in some states maybe, but yeah, okay. So the assertion test didn't help much. Yes, but I didn't really get what you were doing here. Otherwise, this is a good one. I think there's not much to say about this. This is fine. It's using most of the things. Of course, in a realistic one, you will get, in a more realistic model-based testing, you will get a larger model and you will have more complex logic going on. But it also shows you a little bit the problems with this type of modeling, that if the logic gets, even in this simple case, you have like logic spread out, and if the model grows and the complexity of the logic you need to model grows, then this type of models can be challenging, but for sure they will help you understand your system in more detail and so on. Let's do one more, a good one. Based on the Google Guava library, a description of the behavior of the model part of the suit. This is good, so give some background, help people out to understand what you're doing. There's even a reference here. It's a library that provides a bundle of utilities that help developers create immutable collections, probably, perform easier file write-read functions, and much more. Okay, so it was a little bit unclear to me here. Maybe it's just a language issue. I think being more concrete would have helped. The purpose of this library is to help developers remove the amount of effort required to implement their features. It's quite abstract here. I mean, make it more concrete, then it's easier to read and understand. In order to test the features that this library provides, I decided to construct a simple car program which allows. Okay, so you're using an underlying, a generic Google Guava library. So you're creating your own application on top of that in order to test it. Okay, fair enough. Maybe again here, describe why you're doing things. So this will be important for all of you in the exam, and not only state that you did something, explain why, and give meaningful explanation. Don't say general things like because Robert said so in the course, or Jan did this. I mean, give the actual reason for why you're doing something, right? The technical, the down to earth, the real reason, not about someone told you or something generic that because it is good to have automated testing. Yeah, but that's not specific enough. You need to be specific and clear when you describe why you're doing things, why you're taking certain decisions, right? Okay, so simple car program, add car objects into the list, convert the list into a string, and read and write that data to a text file, check whether the data contains any null or find specific patterns. Okay. And good here, so you had some inspiration from somewhere, then you should reference it. Graphical representation, it's a little bit small. Let's dive in. So what do we have? We start here, we have an empty car list. We set some variables to 0. We read from a file. Then we get a car list from file and we store to list. C is F. A little bit unclear what F is here. So you would have needed to describe here. So intro is fine, if a bit abstract. Then before you came to the graphical representation, it would have been easier if you described your states and possibly some key actions and variables. Because now I'm a bit lost when I come into your report. But we'll go on and try anyway. So we go from car list, from file to being in a car list. So this is not very descriptive, the state name here. What does it mean, car list? Yeah, I know the whole thing is about a car list, but what is this state representing, right? So without now the list of states and without clear description of what this particular state means, I'm a little bit lost. So here we can add cars to the list. Okay, fair enough. We can also do that from the empty one. Yes, then we have more cars. We can convert to string the list. Yeah, car list stringified. And then we can, when we have a list, we can check if null, we can check for pattern. Okay, seems to me that here you would probably need a few more states. Maybe the assignment didn't require that, but you know, if I'm talking in general, it can often happen that you sort of abstract away too much. And I think the pattern matching and the null checking seems to be the more interesting logic of this suit. So I would have liked to see a little bit more refinement there in details. But anyway, this, you know, in the exam, for example, there will be more specific requests for things you should cover. And then maybe if it had said that describing in detail how the pattern matching goes, of course, then you would have done it, right? And you would have probably need a few states and transitions here. Write to file, and then we get a file instance and F and S. So F, S, C I can understand, F and S not so clear. So you would have needed some more description before you get into this model. Because otherwise I'm a bit lost, right? I can see what the structure of the model is and how complex it is, but I don't really know what things mean, so I would take it in a different order. Maybe it comes here. Okay, here it is, right? So maybe it was just a lattice layout thing that it came up here, so I should have read it in a different way. But here we say create a list of system inputs from the model. Create car list, add car, convert to string, write to file, report. Okay, maybe that's fine. Here's okay. I constructed the table with all the inputs. Create car list. Where's that? Yeah, maybe they are here, but the mapping from this model to your inputs here is not super clear to me, but probably they are all in there. So clarifying a little bit more with text here what this is and how it connects in detail to your model. An alignment between naming is important. Transition table looks fine. You have also specific actions here, but still the F and the C and the S wasn't described, so here there will probably be a few points deducted for this if you did this in the exam, because it's not so easy to follow. You have to guess as the reader what your variables mean and so on, especially with this type of naming. So that's the downside. Findings: in the random path, the test runs through the model in a completely random manner. This means that the test will always provide slightly different results each time. Yeah. Took about, yeah, I mean, all of the models you did in the assignments are small, but in reality with complex models these times can be quite substantial. Same time, so doesn't seem to be a lot of difference you found here, but again, I mean, a table would have made this a little bit more clear. So, you know, clarity. Think about the reader always when you write a report, whatever it is, and when you're writing an exam, think about the teacher or someone, right? So do things in order. Don't mangle things up in any order, and be clear. Use tables. Use consistent naming. Align models with names in tables and your text. These are some general observations. 5 test. The first test in the model test whether car object can be added to the card. Okay. So you describe the test in detail in text, which is fine. It would probably been good if you had some code example here to make it more concrete, but maybe that's available in the rest. Anyway, that was that one. Okay, we're getting maybe too long here. Let's do one more. Calendar. Assignment 2 report, part 1, description. The model represents a simple calendar system where calendar events can be created, edited. Oh, this sounds a little bit more, could be a little bit more complex. Let's see what abstraction level was chosen. The first edge between start. Okay, so you need to give us more introduction and description here. You can't jump from a one sentence general description to detailed edge and state names. You have to lead the reader into it. Think about your peers. You cannot assume everyone reading your reports or your models will have the same background. Not even yourself in 2 months will remember everything. So you need to give people more introduction and more detail, right? And take things logically. First, give a clear delineation. What are you focusing on? Why did you focus on that? What is it that you're modeling? Then come basic building blocks like probably vertices, states first, and then transitions, events, and so on, right? So you build it up so the reader can understand in their mind what you're doing. Initializes the E variable. You don't. Okay, I can understand you want short names, but this is not very descriptive. The amount of events, so n events or probably n events or num events or something like that would have been a better name. Create new event creates a new event, increments the event counter, makes sense. Delete event input removes all the events from the calendar. Okay, so it's like a reset. Once an event is created, it can also be selected. Okay, interesting. Once selected, the event can be edited as well as deleted. Oh, nice. If there is only exists one event, if it is deleted, the model will return. Okay, yeah. It's a simple model, but it has some interesting aspects and it's a little bit different. Calendar API, yeah. If you want more details. Create new event, delete event. Okay, fair. Descriptions seem okay. Click delete. This is a little bit. This is the action the user takes to do this. I would be a little bit more verbose here. Not only this, it seems you're missing. It's not clear to me what. This is not only the description. This is more like what is the user doing to create this input to the model. So I would do a little bit more here. But okay, you have simple inputs here that are almost self-describing. Here it's a little bit unclear what you're doing here. Events none. So I'm here I'm lost. What is n in your model? You need to give people specifics about your model. Don't just list things in tables. You have to give text so they understand what's going on. And also your state descriptions here are not so clear to me what they are. So you're saying like the type here, yeah. So maybe these names will become clear when we come to what look at your more graphical model. But you probably could have introduced here what is your naming strategy here, right? Okay, here we go. So we have start. That would be nicer to sort of clearly make different because it's a special type of state. We start, we put the number of events to 0, right? So we're in the no events. Then we can only one outgoing. So we look at first and the outgoing to see what's going on to understand the state. So we have no events. Create new event will increment the number. So we have at least one event created. What can happen here? We can create more, then we still, so then the naming isn't perfect, right? So non-empty events, or I don't know what to call it, but anyway. Here's also another outgoing select event. This is nice, so selected. You can then delete it. So the guard is that you must have at least one, then you can take it away. Yes, good. You can also edit, and then it doesn't change, and then you can reset, and then yes, you need at least one because it was already selected, but that would be a guard here, right? So that this model lacks a guard here, which is you need to have one, and it's here, so it's a little bit unclear what you're doing here. Probably you could also do a reset even if you have none. I'm not sure, maybe not, but you know, a little bit strange the division here between the guards, but you know, could be fine to do it like this if you had described why. Okay, with text. Reaching full transition coverage, yes, fast. Okay, yeah, this model was so simple in the sense, so you know, almost any method will work, and there's not much benefit. So the benefit of more complex generation strategies will be when you have more complex logic, right? So if you've looked at the example in the Sultana paper using OCL, you see much more complex OCL conditions for transitions and states there. So multiple times. So okay, description of test, creation of new events, embed event count in the set and the event count in the model to make sure that the event was properly added. How to fail them not properly executing command. Okay, this was a little bit better. I think you could have been more expressive here. So that you really understand, but this way to describe the test was more helpful to me. Pretty challenging to set up. Google, okay. It's extremely robust. Yeah, of course, this is a much used API. So, but when you're developing new software in a company later, you will need testing, and model-based testing might be good. So this is a little bit different, of course, for the assignment. Overall, pretty good. I mean, the model is simple, but it had some interesting kinks with the selection and editing and so on. I still lack a little bit details. I lack the why did you do things. I mean, we didn't request it, but I mean, I'm talking now for the written exam. Focus on that. Think about the order you present things, build it up from simple description of names and events and so on. So that's what I would say. Hopefully this was a little bit enlightenment for you and feedback, and to see what we look for and in when you do these type of tasks. So thank you very much.